So we're going to continue where we left off with the last video, which is thinking about market failures as detriments to the efficiency of environmental solutions and environmental outcomes. And so while we considered externalities in the previous video, we're going to, in this video, consider what happens when we fail to recognize a public good. To do this, we're going to need to consider different types of goods or tangible products or services which can be traded, bought, sold in markets. And this is going to then lend itself to a conversation about the tragedy of the commons, which will then motivate our discussion of public goods. So contrary to a private good, to most things that we think of as being bought, sold, and traded, such as food or technological products, a public good is a good that is going to be non-rival, meaning that one individual's consumption of the good does not diminish the amount of the good available to others, and it's going to be non-excludable, meaning that one person would have the right to consume a good and you can't stop anybody else from consuming it despite that right to consume the good on your own. So using these two dimensions of defining goods, being whether they are rivalrous and whether they're excludable, we can not only differentiate between pure public goods and pure private goods, but also create two other categories such as common goods and club goods. And so a pure public good is going to be non-rivalrous and non-excludable, and a pure private good is going to be both rivalrous and excludable. So let's think about what these definitions would imply about different types of goods and what some examples may be. So a pure private good, I like thinking of the example of food here, that if I buy a donut, my consumption of that donut means somebody else can't consume it, and I can prevent others from getting enjoyment out of that donut by eating it myself. A pure public good, the best examples here are traditionally lighthouses. We could also think of highways, or also like a public park. And if we think about going to a park, when one person walks in, that doesn't mean that somebody else can't walk in. They can't enjoy it. And I can't keep somebody else from enjoying the benefits of that park. And so it's going to be non-rivalrous. There's not a limit on a realistic limit on the number of people who can be in there. And if it's open to the public, it's going to be non-excludable as well. So what about the other two types of goods, the club goods and the common resource goods? So club goods you want to think of as pretty much belonging to like a membership club or having access to something like Spotify, where it's going to be excludable. You have to pay a fee to be able to enjoy the benefits, but it's not going to be rivalrous, because by one person listening to Spotify, that doesn't mean that somebody else can't listen to Spotify. You're not competing over access to the goods, but we can keep people from enjoying them by paying a fee. Golf clubs, Costco, everything like that would also be considered a club good. Now, a common pool resource is what we're going to look at a little bit more closely today, and that's thinking about maybe the grazing commons or open ocean fisheries, where it's going to be non-excludable. We can't keep people from enjoying the benefits of consumption of resources within that pool, but it is going to be rivalrous. So by one person pulling a fish out of the ocean, that means that somebody else can't pull that same fish out of the ocean. And so when we think about these different ways of categorizing goods, it's going to imply different forms of solutions for environmental problems related to these types of goods. And we'll study that in a little more depth in this video. So as I was suggesting in the previous slide, some of the most common examples of common goods are the grazing commons, and I just said common 3 times in a row, or open access fisheries. And so for both of these types of goods, there is an incentive to overexploit these resources, which could lead to a collapse of the resource itself. And it's kind of a form of the fallacy of composition, where what is smart for one is dumb for all. It's good for one person to do it personally, but if everybody follows that same sort of behavior, then everybody's going to be made worse off. And this is something that maybe seems intuitive to us now, but when you're involved in these sorts of problems or situations, it's hard to think of what a proper solution would be. And if these solutions aren't implemented, it can lead to the complete collapse of that resource. And so we saw this with bluefin tuna, in part because they are slow growing and they exist in the open ocean with the lack of jurisdictional boundaries on who has the rights to extract those fish. And so as you can see from this map, a lot of the bluefin tuna catch is occurring in international waters. And so it's hard to think of how in any way that could be excludable. And so while it's not excludable, it is rivalrous, because once again, you pull one fish out of the water, it means somebody else can't pull that same fish out of the water. And so this is a clear example then of a common good. And just in case any of you are tuna eaters out there, though the bluefin tuna is a way that, is a type of fish that is slow growing and we can overexploit, skipjack tuna, you can get it relatively cheaply from Aldi, is a faster growing, smaller tuna that's more sustainably harvested. And so it's less prone to this tragedy of the commons type problem. So the more you know. All right, so what I'd like to do now is illustrate graphically how we can see the tragedy of the commons occurring and what that discrepancy between the incentives for society and the incentives for the individual ends up leading to. And so we know from the videos for the past couple of weeks that the efficient solutions for society occur where the marginal social benefit equals the marginal social cost. And in this case, we can see the marginal benefits to society and the marginal cost intersect with Q star units number of cattle on the common pasture. And so we can just say this is 3 for now. And that's going to give us a solution where the marginal benefit of 1 more cattle grazing on the common land is going to equal the marginal cost equal to the marginal benefit. And this leaves some grass for the future, which provides the option value of maintaining the grazing commons going forward. However, under open access, every individual will have an incentive to use up as much of the resource as they can, otherwise somebody else will. So there is no protection of that option value because you're not leaving any for yourself in the future, it's just going to go to somebody else. And so the open access outcome is going to be where the average benefit, the benefit on a per person basis, is going to equal the average cost. And as you can see here, because the marginal cost is just equal to 2, the average cost is going to be equal to 2 as well in this case. It's just going to be that constant flat line. And so we then arrive at a solution where the Q open access is greater than Q star, and we overexploit that resource and deplete it to the point where it's not going to be able to regenerate. And from an individual perspective, not thinking about the value of society, if they believe that others are going to also act maybe rationally, but in a very limited way and only thinking of their short-term interests, and that's the right thing for them to do, but it's to the detriment of society. And so this was made famous by Garrett Hardin. He pointed out that under that open access, as we've been saying, every individual has an incentive to extract the resource up to the point where the average revenue equals the average cost. The revenue and costs on a per person basis are equal, which leads to zero profits or zero surplus, which is obviously going to be inferior to the outcome where we could have a collectively planned or collectively agreed upon outcome. And so this then leads to the overexploitation of that resource. So we can think of three ways of kind of designing principles for governing the commons to prevent the tragedy of the commons. We think of command and control policies, maybe a little more heavy-handed government intervention as a way to say, look, we know what's in the best interest here, and if we don't do this, you're going to end up with this big brown patch of no grass and all your sheep are going to starve. So we're going to tell you what we need to do. We can appeal to cultural norms and use kind of societal pressure and social capital as a way to structure our management of the commons without relying on a centralized hand from the government. And we can have a more laissez-faire approach by the government, which just consists of creating property rights and allowing people to trade according to those property rights. So when we think about command and control, this could potentially limit or even completely avoid the tragedy of the commons, but it may be ineffective or inefficient. And as we've said, multiple times throughout this term, efficiency matters. It means that we can do more good with a limited amount of resources, that we can provide healthcare and education in addition to just protecting the environment. And by creating an inefficient policy through a command and control approach, we may be limiting the good we can do elsewhere. So an example of applying a command and control approach to the grazing commons would be if the local lord would say, you can only graze your cattle for 1 hour a day, or they would charge the peasants to use the land and come up with a not a market regulated solution, but just telling them what they can and cannot do. So while the tragedy of the commons was first defined by Garrett Hardin, who is a biologist, one of the more famous and recent scholars to address management strategies for the tragedy of the commons was Elinor Ostrom. And so Elinor Ostrom is actually a political scientist, but was the first female winner of the Nobel Prize in economics. And recently, so she won it a little over 10 years ago, just not this past year, but the year before, was the second instance of a non-male winning the Nobel Prize in economics. And you can probably guess how that went over, or how the media. So I just want to take a quick intentional sidetrack to discuss this a little bit further. And so this is a photo of Esther Duflo and Abhijit Banerjee, who along with Michael Kramer won the Nobel Prize in economics a couple years ago, 2 years ago now, for some really great work in development economics and actually applying the epistemological process about how we generate knowledge in economics from how it is done in the medical sciences, thinking about randomized controlled trials to learn about the efficacy of different treatment options. And these scholars all applied that to learning how we can improve the lives of people in developing countries through targeted and direct interventions. And so Esther Duflo and Abhijit Banerjee are married, and you can probably guess how the media treated the news of both of them winning the Nobel Prize in Economics, which was really just treating Esther Duflo as the wife of one of the winners rather than the winner herself, as she truly was. And so this is just, one of many examples of there being this implicit bias against women and people from marginalized communities in discussion of academic work. And part of, I think, how we get beyond this is we name and award more female winners of the Nobel Prize in Economics rather than just two through, what is it, like 70, 60 years now. So this is something that the discipline of economics needs to make a much more conscious effort of going forward. And though we can't control the journalism surrounding what we do in the discipline, we can at least make it more common so that it's less noteworthy and less susceptible to malpractice in journalism when it is the case. And so to return to Elinor Ostrom and her Nobel Prize winning work, looking at how we can govern the commons using cultural norms, she studied societies throughout the world and over the course of time, which came up with internal solutions for managing the commons and avoiding the tragedy of the commons, not through an external government forcing a solution on them, but by realizing that they could manage these concerns not by explicit economic penalties, but by social penalties, and having social disapproval as a way of disincentivizing overfishing or overgrazing. However, these were found to be most successful if the groups were small, stable, and self-governing. And so that's obviously not going to apply to every type of common good resource problems. And so one of the last ways we can think about managing the commons is through privatization. And this kind of sounds like a dirty word when we think about the privatization of industries in the 1980s in the UK and the US. This is a way that we ended up exploiting labor at the expense of, or to benefit the more established and wealthier corporate owners. However, there are efficiencies which we can gain from privatization, and really just to think about privatization as another word for creating markets. And we're going to talk about individual transferable quotas more when we talk about resource economics. And once again, the difference between resource economics and environmental economics is slight, but we're going to discuss this more during the 9th and 10th week of the term. But for now, just know that this is a different way that we can manage the tragedy of the commons or prevent it, is by creating these tradable quotas, which involve some form of a command and control approach to come up with the total number of permits or quotas necessary, and then to create a market where boats can transfer, in the case of fishing, boats can transfer permits for catching fish based on who is most efficient at doing so. And so this is a little bit more of a hands-off approach, in that there's no restrictions on boat size or equipment, and that we can allow more or less the free market to create the efficiencies by setting the marginal costs equal that we've seen in graphs so far. So the question then really becomes, if markets can help us arrive at efficient outcomes, why can't we just rely on them from the beginning to produce efficient amounts of public goods like biodiversity or conservation? And so in the classic externality case of a negative externality being imposed by the production of a good, this often leads to the marginal social cost being greater than the marginal private cost, and it leads to overproduction of the good, where the costs exceed the benefits for a number of units produced, and the price of the polluting good is too low and too much of it is produced. When we think about public goods, this is going to look a lot more like the case of a positive externality, which is unrecognized, but it's going to have some subtle differences, which we'll discuss in the second half of this video. And the outcome, though, is going to be the same, that an unregulated market which fails to recognize a public good is going to underprovide that public good. And it's going to look more like that case of a positive externality, where we're going to produce QM units rather than Q star units, meaning that from this triangle of A, E, O is going to be unrealized gains from trade, that we could benefit both consumers and producers by producing more and at a higher price. However, is going to be underprovided if we let the free market dictate the outcome and we don't externally enforce the recognition of a public good. So in the case of public goods, this inefficiency is going to arise from a difference in how we calculate the aggregate demand, the aggregate benefit, societal benefit curve from individual demand curves. When we have a private good, when we think about the demand, the market demand for food, for apples, then, or in this case for ice cream cones, I could use the example I have illustrated, then what we do is we calculate the market demand curve by adding up the individual demand curves horizontally. And so we add the quantity at each price, and we end up getting a market demand curve which looks maybe flatter. So in this case, we know that at a price of $2, there are 2 cones demanded by individual 1. At a price of $2, there's 1 cone demanded by individual 2. And so the market demand curve, the quantity demanded at $2 would be 3 cones. And we would do the same thing for each price on that demand curve. We would add up the quantity and we would get this horizontally aggregated market demand curve. Public goods are going to be the exact opposite, that instead of seeing what the total market quantity demanded would be at each price, we instead are going to see what is the willingness to pay. Remember, returning to that those other letters, those other definitions of the demand curve, marginal benefit and willingness to pay, for each individual, for each quantity, and we're going to add those together. So if we think about an example where we have 2 roommates living together and they both value having a cleaner shared living space differently, then we can add the value for each hour of room cleaning to calculate what the public good social benefit curve would be for both roommates combined. So we can look at this first roommate on the left, valuing their first hour of room cleaning at $4. And so they obviously place more value on having a cleaner room than the second roommate, who's only going to value that first hour of cleaning the shared living space at $2.50. And the same would hold for the second hour, that the first roommate would value that second hour of cleaning the room at a little bit over $3, and the second roommate would only value it at $2. And so if we add the value for each hour together, then we can see what the total value to the roommates would be for each hour of cleaning. And so adding 4 and over like 2.5 for that first hour, we can see that the societal benefit curve, the public good demand curve, would equal 6.5 for that first hour. It would equal 5.5 for the second hour, and so on. So this is the fundamental difference between private goods and public goods. Is private goods, we create the market demand curve by adding the quantities at each price, and for public goods, we create the aggregate demand curve by adding the prices for each quantity. So the problem with public goods and with when we have public goods, when we treat them like private goods, is that this creates incentives for free riders, or someone who would derive benefit from a good or service that they don't contribute to the supply of. So somebody who is going to recognize that a good is going to be provided on the market because somebody else values it more. And this is going to mean if we don't recognize public goods for what they are, then we're going to have the wrong marginal benefits curve. And this is going to mean that the promise of efficiency from the intersection of the demand curve, which is marginal benefit, and the supply curve is going to be misfounded, is going to not represent the true optimal outcome. So this is similar to the tragedy of commons in a way, where there's a difference between what is in the best interest of an individual and what is in the best interest of society. And individuals will then act in a way as if all other individuals are going to act similarly, that they are going to have no trust in everybody else to do what's in the best interest of society and expect everybody else to do what's in the best interest of themselves. And so when something has a personal cost but a common benefit, individuals or economic agents will underinvest in that good or service, and that underinvestment then results in too little of the public good being provided. And so, we can think of something like Wikipedia or file sharing services, and that it's easy for people to get benefit from it. We all use it, but hardly any of us contribute to it. And if that's the case, then there is going to be a under provisioning of those services without external sources of fundraising, such as all those like once or a couple times a year when Wikipedia will start requesting donations to fund their services. So returning to the supply and demand way of thinking about public goods versus private goods and how we calculate the aggregate demand curve, we can see that when we add the quantity at each price for the individuals, we're able to get the market demand curve. So, for example, if we look at what the quantity demanded would be for both individuals when the price is 0, we see that it would be 7 for Ben, it would be 16 for Kathy, and it's 23 for the two of them. Similarly, when the price is $8, there's 0 demanded by both Ben and Kathy, and so the market demand curve is 0 as well. Now, when we have a public good, that is going to be, once again, the opposite case. We're going to see what is the willingness to pay for the first unit for individual A, what's the willingness to pay for the first unit for individual B, and then what do we get if we add those two together. And so for individual A, it's $5, for individual B, it's $6, and so when we add them together, we get 11. And importantly here, you're going to note that there is a kink in the aggregate demand curve where the demand for, at the quantity, where the willingness to pay or the marginal benefit for that quantity for one individual is 0. And so individual B has 0 marginal benefit for any consumption beyond the 4th unit. And so for the 5th and 6th unit, in this case thinking about streetlights, there is 0 benefit from B, and so the aggregate demand curve just follows individual A's demand curve. And so it comes down like this, and then it equals individual A's individual demand curve for the units at which individual B has no willingness to pay or marginal benefit. So thinking about this information in tabular form instead of graphically, we can see how each of these individuals would have different willingness to pay, different marginal benefit for each unit of consumption, for each streetlight. And streetlights here are a good example of a public good because you cannot keep somebody else from enjoying the benefits of a streetlight which you pay for. Its light is dispersed, and it's going to be non-rivalrous. You obtaining vision from a light in the nighttime does not does not consume any of that amount of light. There's still plenty to go around for other people. So at the top of these two tables, we have their demand equations, which this is an important note in economics. The demand equation is going to have the quantity as the dependent variable because we think of individuals responding to prices and changing their consumption of a good when the price of that good changes. We don't think of the price of the good changing in response to a change in the consumption of that good by an individual, because we think of individuals as being price takers rather than price setters. And so how do they change their consumption in response to prices, or what is the willingness to pay for the quantity demanded? Well, resident A's willingness to pay for that very first streetlight is $5, and if we look over here for resident B, their willingness to pay for that very first streetlight is $6. So how do we add these two? Well, we're going to want to sum them vertically, and to do so, it's going to help if we rewrite the demand equations as inverse demand functions. So instead of listing Q equals an intercept minus the slope, we're going to rearrange that to solve for P. And so that way we can see if we add those demand curves, in this case, the inverse demand curves of P equals 6 minus Q and P equals 8 minus 2Q, we can see that the intercept would be 14. It would be 6 plus 8, and that's exactly what we would get if we would aggregate the willingness to pay at that first, for that first marginal unit of consumption. And so we're going to need to do this for each quantity, because importantly, once the price equals 0 for one of the individuals, there comes a point where there's going to be no additional streetlights demanded, even though the price is free, that they are satiated and they've consumed the maximum amount, or they've demonstrated what the maximum amount they'd be willing to consume regardless of the price. And so once we calculate the aggregate willingness to pay, the social benefit for each individual quantity, by adding the price along each individual's demand curve, then we could illustrate what this aggregate demand curve would be by plotting their willingness to pay, or the price per unit of consumption, by the number of units consumed. And so we end up illustrating that kinked aggregate demand curve that we were describing earlier. And when we do so, if there's a constant marginal cost, again here of, let's just say $2, then we could see that by treating these streetlights as public goods, we're going to have a socially desirable distribution or socially desirable allocation of streetlights, so that we make that determination where the marginal cost curve intersects the aggregate marginal benefit curve. And so we would have 4 streetlights. However, if we treated these streetlights as private goods, then we would want to aggregate our individual demand curves horizontally rather than vertically, and we could add up what the quantity demanded would be at each price. So at a price of $2, for example, individual B consumes or would demand 3 streetlights, individual A would demand 4, and so the socially optimal number of streetlights at a price of $2 would be 7 streetlights. Now, we can compare that to what would be the case if the marginal cost of streetlights was higher. And we can see that if we treated streetlights as private goods and we aggregated the demand curves horizontally, we would add the quantity demanded for individuals A and B at a price of $6, and we'd see that at a price of $6, individual A doesn't demand any streetlights, individual B only demands 1, and so the socially optimal number of streetlights to be provided would be 1 streetlight. However, when we treat it like a public good, we can look at the graph, or we can look at our table and see that at a price, I guess with the table we can't quite see that. So we look at the graph and we'd see at a price of $6, the optimal number of streetlights to be provided, where the social marginal benefit equals the marginal cost, would be just shy of 3. And so the implication for whether or not a good should be treated as a public or private good is going to differ based on the marginal cost of the good that's provided. And so these public goods are going to, or recognizing a public good for what it is going to be more beneficial when the marginal cost is higher, and treating the public good as a private good may actually be beneficial when that marginal cost is lower. But the efficient solution is always going to be derived by treating public goods as public goods, private goods as private goods. And when we have a good which is non-rivalrous and non-excludable, then we want to create the aggregate demand curve, the marginal social benefit curve, by adding the individual demand curves vertically, calculating what the willingness to pay is for every individual quantity, and adding that willingness to pay for each quantity to calculate what the aggregate demand curve would be. So in summary, thinking about public goods and the tragedy of the commons, a pure public good is going to be non-rivalrous and non-excludable. The tragedy of the commons is the tendency of a common resource to be overexploited and under-maintained when that good is going to be non-excludable but rivalrous. The free rider problem is going to arise when the good is a public good, and that we can think of having command and control strategies, social norms, and the establishment of property rights for governing the commons. And we're going to talk about this very last, this last strategy of creating property rights in our next video, and consider what exactly property rights are and how having properly defined property rights can create more efficient solutions so that our marginal benefits are in line with our marginal costs.